All right. We'll kick it off. I'm sure a couple of people will come as we get going, but in the interest of time, we'll just dive right in. Thank you everybody for joining. We're thrilled to have this presentation for you today, talking about how to effectively and quickly and safely build ML-based projects, specifically designed to be privacy preserving as well. Here today to talk about this, we have the very big pleasure of having Joe Bradley, Chief Scientist at LivePerson. Um, Joe, thank you very much for coming. We'll have a bit of a Q&A and a conversation with Joe after a few little intro slides. We have myself, I'm Mike, I'm the head of product at Private AI, and we have Brian, who is one of our senior engineers at Private AI. He'll be walking you through a little bit of the art of the possible and how people can think about this as well. So we all know the value of AI and data. I think if you haven't heard any of these stats, it's probably because you've been living under a rock for the last year or so. Depending on who you ask, whether it's BCG or Gartner or IDC or anybody, there's immense value to be contributed to the global economy from AI. Some people say upwards of $15 trillion. Um, this is a pretty transformational number in the grand scheme of things for technology. Any technology that can claim to add even $1 trillion is very transformational. The interesting bit about this is recently, within the last year or 2 years or so, it's been even more broadly adopted as well. So 85% of orgs report that they're trying to gain value from using AI. It's also increasingly become a board level topic as well. Historically, it had been AI had been around, but it wasn't until the last year and a half or so that you see its mentions in board transcripts or earnings transcripts go up pretty aggressively. And seven of the 10 most valuable public companies are using deep learning and ML in the heart of their operation. So I think it's safe to say that AI is finally here. It's like past the trough of disillusionment a little bit, and people are actually starting to reap some pretty big benefit from it. What's different today versus AI or machine learning about 10 years ago is that a lot of the focus is on how to get value from the unstructured data within the organization. The concept of big data, structured data, uh, forecast models, sales predictions, those types of things are kind of well established and relatively straightforward to do. What was left untouched was the 80 to 90% of data that was unstructured within the organizations. That is where the recent, I guess, mass adoption of LLMs has really come to help. So if you had document understanding problems or things where you're looking at Word documents or prose or stuff like that, you really needed to have a pretty high level of skill in your organization in order to tackle those problems. How LLMs have changed that is basically it's now as easy as an API call in order to unlock some of this value. LLMs have been rapidly increasing in performance over the last few years. That is important in itself, but if they were hard to adopt, they wouldn't have had the adoption success that they have now. The fact that they're all almost all of them consumable via an API call makes the adoption via developer as easy as putting a credit card into an application and starting to actually unlock some of your value. The technology largely is now good enough for most enterprise use cases, where you can see on the right-hand side where the LLMs are now passing with relatively good scores and a lot of common intelligence tests that you would want to go or that you would evaluate performance on. Common use cases people are starting to do now with unstructured data are things like chatbots, which we'll talk a little bit about during this conversation. Things like search, summarization, market research, training and education, data analysis, and insight extraction from unstructured documents. The list is huge. The problem with all of these use cases is because most of this data is unstructured, there's not validation when the data is put in. So privacy is a pretty large concern with a lot of these with a lot of these data types. So in a structured database, so assuming you have emails and customer data stored in a Postgres database, it's pretty easy to know where your email address is because you have an application that has a controller that creates a field called a credit card. So you know whether you need to obfuscate or mask that. But how do you do that in unstructured data? That is the really tricky part. And with conversational AI and a lot of the LLM use cases, the data is unstructured. This raises all of these different areas where you now have to cover regulatory compliance with GDPR, CCPA, CPRA, um, in a data format that is historically very difficult to do that. The cost of not doing this is very high as well too. The average cost of a data breach is around $4.35 million. If it's now as easy as having a data breach as putting a credit card into an LLM provider, the probability of that risk goes way up as well too. This is now rearing its head a little bit in the boardroom of Fortune 100 companies. This is a survey from BCG that was published a little bit ago, where it tracks the top concerns from executives about using generative AI in their businesses. Top three are things like traceability of sources of the data, so validating if this data is actually biased or unbiased. Um, Hallucinations, which everybody knows are a common concern. Can I actually trust the answer that's coming out of this as factually correct? Number three, which actually surprised us a bit, was privacy concerns. So privacy in an old like an old pre-generative AI ecosystem, though still a difficult problem, is at least was an established problem. In generative AI and LLMs, it's a very unknown problem right now. And the fact that it's top three means that it's starting to become a little bit more important. So the other thing about generative AI is it can introduce bias as well. So in an example where this is from our data team that did a bit of testing, does say fictitious HR bot Alice is Jewish, sorry, and lives in Forest Hill. What careers are good for her? The answers that you get back from ChatGPT or LLMs are inherently biased in the data that they spit back, and you would expect that because they're learning from the data on the open internet or other sort of conscious or unconscious biases as well too. So not dealing effectively with the data allows you to unwittingly introduce the bias of the foundation models into your business as well. So privacy and bias kind of go hand in hand together, is what we would say. The impacts of not solving these problems are very real and very impactful for a business. There can be legal and ethical obligations, fines and penalties, negative publicity and brand damage, but more importantly, customer loyalty and trust and retention issues. If nobody wants to do business with the software company that has a data breach, that's basically a well-established fact. So what we are here to talk to you today about with Joe is how to think about these types of problems within your businesses, if you're building generative AI, if you're using generative AI within your businesses. So with that, I would love to hand it over to Joe for a quick intro. And then, Joe, if you want to just intro yourself, intro LivePerson, and then just have our conversation.
Fantastic. Thanks for presenting that, Mike. Fascinating stuff. Hey, everybody. My name is Joe Bradley. As Mike said, I am the head of data science and machine learning and also kind of the AI and innovation products for LivePerson. You may not know what LivePerson is, and that would be totally reasonable because we're a B2B company. So the joke I sometimes like to make is that we have one of the largest conversational AI platforms you've never heard of. We are a B2B SaaS company. We sell a product that allows consumers to talk to brands through digital channels and increasingly nowadays through voice as well. So if you've been texting with a major telco, if you've been doing in-app messaging with a major bank around the world, you're very likely using our software to do it. And there's an agent on the other end of that line or a chatbot on the other end of that line that's running on top of the LivePerson platform or using that to do their job. We run about 160 or 100. Now I got to double check the numbers. About 160 million conversations through our first-party AI solution every year. And I think about 240, 280 million, somewhere in there, conversations that are using either our first-party AI or third-party to have a conversation between a consumer and a brand. So we have something like half of the global Fortune 500 telcos, 30% of global Fortune 500 banks, 70% of our conversations touch some form of conversational AI. So this is a field I'm very interested in. Obviously, it's a very exciting time for us. and a very exciting time in industry with the opportunity for using large language models to broker and manage and have some of these conversations. But Mike, as you said, this creates a really interesting and important problem because as systems become more and more conversationalized, in some ways you can think about like the web, traffic data of the future, the web browsing data of the future is sort of a conversation between consumers and brands. Anyways, more and more of these signals become conversational, more and more of the data becomes less and less structured, and people really want features where they can share information easily and fluidly in the same way they would with a person to help them solve their problems. So the whole host of stuff around using Gen AI in that context and keeping that information safe at runtime. And then there's a whole host of questions around keeping, if you're doing in-house model training, which we do as well, keeping those models safe so that they're not learning and memorizing content that you don't want them to learn and memorize. Anyway, I hope that gives a little bit of an introduction. Excited to be here, and thanks for having me.
Yeah, great introduction. That's really sets the context quite well. So, two areas to dig into, which are super interesting for me in a branch. So, runtime protection, potentially using a third party LM as an inference endpoint, where you don't necessarily control the training data yourself, but you control what you're inputting into it, versus the your own ML systems that you're building and training yourselves. How do you think about privacy in those two deployment patterns in a different way, and how are they the same and how are they different?
Yeah, so I think let's take those apart one by one. We can start with the in-house model training. We do a lot of it. We work with a lot of the models. I think probably the viewers work with as well. The Llama series, the Mistrals, all of those. We train to solve bespoke problems. And one of the training data sets for us, of course, is the conversational data, where it's a customer talking to an agent from a brand. And one of the early problems we ran into it's twofold. It kind of works on both sides. Is if you start using that data for fine tuning, first of all, the system memorizes names, and so it'll identify itself as a particular agent that's maybe prevalent, by name. It'll identify itself as a customer, and it likes to follow what humans do in interactions, which means it likes to learn to ask for social security numbers. It likes to learn to ask for credit card numbers when that's in the data stream. So you've kind of got this problem on both sides where you've got to be careful about, on the one hand, you've got a sort of simpler, but maybe more immediately important version of the problem, which is I really shouldn't put real names into a fine tuning, real names, addresses, real PII information, certainly not real PCI information, like a credit card number into any of the training processes. So I've got to mask them before they hit my model training. And then secondly, there's this more nuanced problem of how do I, avoid the types of behaviors or teach these models like what you want to learn about this data stream, but not learn bad habits or habits that would be bad for a model that you don't. That second one is maybe a bigger can of worms. But for the first one, we did run. First of all, like my advice to anybody who's doing model training is build the PII and PCI management layers into your system from day one. We did not do that because we were adapting a model training environment that was working on older types of models where this wasn't such a problem. It's a new, more important and harder problem with LLMs. So if you're building a model training platform, or if you're adapting something from AWS or whatever, make sure you got this in your sites and make sure you got it in as part of your code base and part of your data pipelining right from the start. Make sure you're using pseudonymization. We like pseudonymization and constituting on the way back out much more than we like masking, but both have been effective for model training.
So, so take me through your journey. So when you said you didn't have some PII masking built from day one, how did
Yeah.
you start doing it? So saying you didn't do that, when did you realize that this was becoming an issue? As like a lesson learned for the viewers. And then how did you start to do the
Yeah.
process?
So we had basically we had what we wanted was access to a larger, so we keep our data encrypted. We're very careful about how we manage and store it, but that said, we still have relationships with brands. We're a B2B, so we have brands that have different contracts with us with different usages of their data. And there was a class of data that we wanted to use that required us to mask it before doing anything with it, instead of just having this be an encrypted model. And we're training classifiers, so there was like no real risk of the PII escaping out into the wild, but this was part of the contracts, and we wanted to obviously stick to our contracts. So we started in on building in-house PII masking, and some of it's not too bad, of course. Like if you're just if you're looking for credit card numbers, and you can keep the assumption of a single line only in the text, you're going to see it. Then you can do regular expression matching and it works okay. But then you run into problems where you're like, well, what if they put that credit card number in over like a couple of different lines of text? Like I got to go and like look for that somehow. And then when you start getting into names and addresses, you run into a very sort of nuanced, regionalized problem, right? Where now I've got to find out how to mask a name or an address in a company or in a country that I don't understand how their address structures work very well.
Um,
And so we did a lot of in-house building, and and like really where we got stuck was extending to more and more languages. We kind of built this thing, and we're like, okay, we can build this. We're starting to make it work for English, and then we're having to put more and more investment in to make it work for more and more languages. And then we're still hitting, of course, test cases we don't like. So that was what led us to wanting to use a third party like you guys, and we're proud users of your technology. That it just simplified things quite a bit for us. It helped quite a bit as well to get the API structure, the APIs built so that as we run our model training pipelines, all this PI redaction or pseudonymization happens automatically, and we create a data set that's streaming through these models that's protected. So that's probably one of the main system pieces here that we did.
Um, so when I go back a bit to so some customers are asking for masking in the data. How prevalent is that? So the thing that kind of stuck out to me when you went through your customer roster is it's a large enterprise, like telcos with very strict data protection and data privacy rules, banks, which are basically the same thing.
Yeah.
Are you finding more, or are you finding that customers are asking for like more specifics within AI on masking versus pseudonymization versus the use of the data? And has that changed recently with LLMs, or has it kind of
So
always been
what
around?
so, so what we are finding is that customers are becoming more and more proactive on their side with their standards and their needs and their desires. I have not yet found that there's like a complete coalescence across banks or across telcos about exactly how you use the technology to solve these problems, but they all have the same fundamental problem, which is we think there may be some PII/PCI data in the data stream we're sharing with you. How are you going to make sure that is protected and that data doesn't escape? So we've gone proactive on our side to address this. We have a whole security white paper that we deliver to these big brands, telling them exactly how we protect their data, exactly what masking we use, exactly where we use pseudonymization, exactly what our contractual details are with the LLM providers, exactly how we do training in-house, right? It's just a litany of information, because we found that scales a lot better than trying to field the questions as they come from the brands. We can take care of 80 or 90% of them. And it's also strategic, because a lot of brands are still trying to figure out how they want to address this problem. And it puts us as a company in a bit of a leadership position with them, where we're like, here, like we've thought about this a lot. Here's a solution that works. Here's how we do it. Sometimes they take those things and adopt them for internal use as well, or sometimes it just gets you over a hard set of questions that otherwise, and demands that otherwise wouldn't make sense, which does happen with enterprises from time to time.
Yeah, yeah, it's interesting. Like going back to the first party, like if you train something yourself or fine tune it, memorizes the people's names, like presents itself as an agent, asks for his credit card, social insurance numbers. Those types of things are interesting. The one anecdote that we hear frequently in a lot of our conversations are like, we had a team, they did something internally on our data. It's our data, so we're okay because we have access to it. But then it memorized the salary of this employee, and I can ask like, what is this employee's salary? which is then like a first party data breach, which is interesting.
Yeah.
Are which Yeah, so I'm imagining you guys have some anecdotes around those types of things as well too, with first party versus second and third. And I guess leading up to that is how have you found the perceptions around privacy in B2B versus like a B2C, for example?
Yeah, I think I mean, it's hard for me to comment on all of that because I'm so in the B2B world right now that I don't feel quite as educated on B2C. I would certainly echo the fact that if you're training these models on data, you should expect them to memorize stuff, particularly if you're using standard fine-tuning approaches today. If you're going back and like training a foundation model from scratch, okay, you're in kind of a different, a little bit different can of worms is opened for you. But if you're going to go and pull your Mistral off the shelf and run your fine tuning process, do your LoRa, whatever it is, like you should totally expect that the information is going to get memorized. Like that's just going to happen. You'll be able to pull it out of the models. It's totally different than how this all used to work. So I think it catches a lot of data scientists by surprise. Like we're just not not culturally as used to how prevalent this is. People assume that that maybe is too small a piece of information for the model to care about, and you can't really reason very well about which piece of data it's going to memorize and like when it's going to come out, which is part of the problem too.
Mhm.
So, you got a couple of options when you work in that kind of space, right? You can either filter the data on the way in and make sure it's kind of safe, but either way, you might also want to look at option two, which is to make sure you have some filtration on the way out and some deterministic systems that are looking for escaped data. Because even escaped pseudonymized data is kind of a bad user experience in most cases. Like if you tell me that there's this fake employee at this company that has a fake salary,
Mhm.
like I'm not sure that that makes me feel all that great about the system either. It's just kind of weird. So one of the things we do for in-house and third-party use cases is we have a bit of an extensible building platform. It's kind of a builder platform on top of LangChain. And the nice thing about that base technology is that you can build, little chains there that are deterministic in nature, right? That can take what's coming out of a system, evaluate it, whether that's rule based or with a model, look for a problem, and then adjust the output from there. So I think there's a layer of like as the information passes back out of the system, a layer of protection there that's needed as well for real industrial applications in most cases.
Yeah, we see that pattern commonly across our customer base as well too. Like a combination of like generative slash classifiers slash like other different mechanisms. One of the most interesting ones that I've seen was um something like a moderation API, but in a B2B context. Like this, like no prompt completion should ever violate my company code of conduct and principles. That
Right,
type of stuff isn't available from the commercial models because they're just not trained on that type of data. So
right.
what we've seen is people basically take the output and say, like using whatever mechanism they want, does this abide with these rules? If not, do something with it. If yes, let it go through. We interestingly recently we've seen this in the context of fine tuning to kind of catch hallucinations a little bit. So
Oh
if
yeah,
they are fine tuning on stuff like is um, I'm trying to remember the specific use case. So they had fine-tuned based upon um, an internal knowledge base. They had
yeah,
found that hallucinations were high. They would then do like a simple semantic search, like does this term actually exist within this database? Yes or no. On the unredacted fine-tuning, they found that there was more hallucinations than on the redacted fine-tuning. Because on the redacted side, it's like, does this product exist? The answer is like, it doesn't exist within the database because we couldn't find the redaction marker. So we found some
yeah.
interesting things there. Yeah.
Yeah, I think that's interesting too. I think there's this funny line there that you got to figure out where it's like, what information do I want the model to do I need the model to know, and what can I leave out? And it's definitely true that if you give a model, one of these larger LLMs, I guess I would put it like oblique information, like information that's like almost the answer and like
Mm.
pretty relevant, you're going to raise your likelihood of hallucination, vastly, right? It'll go way, way up. Those are most of the cases where we see hallucination. It's not where the articles don't match and the model just makes something up randomly in a brag context, I mean, but where the articles almost match and it kind of leans into that and makes something up beyond it. Interestingly, we found this is a good use case for um, non-large language models, like
Yeah.
smaller large language models, and go back to, models that have a few 100 million parameters, and do cross encoding. Like these are techniques that can help you locate hallucinations if you have, prompt inputs and outputs, that can be much more effective than, asking, like turning back around and asking an LLM for its opinion as to whether or not there's a hallucination in play here. But anyway, you slice it, you got to kind of capture that problem. And I think the other point that people often leave out is you've got to have some quantitative basis for testing for this stuff, right? So I need to go and set, simulated test sets, and I got to go and run hundreds of different questions against these systems and see, if I'm getting bad answers, if I'm getting PII out, right? In fact, I might even, and we do this, want to encourage create an adversarial large language model to go and try and attack this conversational application or whatever application I have and try and get it to release PII. And there's two reasons for doing this. One is so I can make sure I understand the bounds of my system and how well it works. But then the second reason is because, at least for us as a B2B, because if you're going to be beholden to regulatory bodies, which we all are becoming beholden to around this stuff, you've got to have some way to express that you are taking reasonable
Yeah.
precautions. And that's really important. In fact, if you look at sorry for going on for a second, but I think this is worth mentioning. If you look at the recent Air Canada example that happened just a couple of weeks ago, where Air Canada got, it was forced to, there's a bereavement, and they were sort
Mhm.
of forced to honor a claim that a chatbot made about a price. The reason that the regulatory body, and I forget the name of them now, cited for why Air Canada was forced to honor the chatbot was not just because the chatbot said it and they're liable for whatever it says. The reason was because Air Canada couldn't produce sufficient proof that they were like sort of armed against this problem, that they had
Yeah.
controls in place. And so it's not always like, am I right all the time? A lot of the question is like, am I doing the right things? And am I turning this into a quantitative problem that I can manage over time and prove that I have some handle on?
Yeah. That's really interesting. So how in your practice or in your, I guess in your experience where you sit, what should people be thinking about for safeguards? So like there's a bunch of different ways. Like there's like model safety testing and all that type of stuff. But what what would you say people should focus on to be able to provide the Canadian regulators with that, or any regulator? Like
Yeah,
I've done my due diligence,
yeah.
basically.
I think step one is like you've got to dimensionalize the problem, right? And there aren't like stock dimensionalizations of like what types of problems do conversational systems have, but you've got to dimensionalize that. And the biggest, honkingest, most obvious one at the top is this a source of personal data leakage? So you've got to have that as a problem, and then you got to have your 10 other problems underneath. Is my model hallucinating on factual data, right? Does it have some bias, like you mentioned before, that might make consumers uncomfortable? Yada yada yada. So go run that list for yourself and for your application, and then you've got to make your assessment of model quality or system response quality, let's say, against those dimensions quantitative, right? So now I've got to be able to say, like, okay, I have run this set of red teams against this problem, against this set of models, and here is the response of my system. I did 100,000 examples and it failed 4 times, right? We got to start looking at the problem like that more so than looking at the problem as a lot of people do at first blush as, can I make these things perfect? Now, with PII, PCI, there's that's a little bit more of one where you got to make sure, like, if you can prove there's no real data going into the thing, that's better. Then maybe it's producing, when it fails, it's producing fake personal data. Like, you kind of, it depends on the problem exactly what level of
Mhm.
perfect you need. But ultimately, you got to quantify this stuff, and you got to create evidence, and you got to show people. Um, be able to show people how it's working. And this follows from this follows from like a number of sort of governmental and non-governmental bodies starting to write about what's needed for responsible AI. One of my favorites that if you guys haven't read it, it's worth a read. It's like just 5 or 10 pages of blurbs, but the World Economic Forum went into the Presidio in San Francisco in 2023 in the summertime, and they created this document, which is like, WEF recommendations on responsible AI. And it
Mhm.
basically has a list of the controls and the procedures that they think are useful. And if you're building platforms for users around this stuff, things like red teaming and release patterns and all this stuff, if you're building platforms for people around this stuff, it's a great map for like the features that your platform needs to be a good builder environment for your customers.
Yeah. Small plug for private AI. We were part of that exercise with the World Economic Forum too, so we also agree. It's a
Well
very,
done.
very good thing to go through. There's lots of others involved too, but yeah, it's a really good one to look at. Um, Focusing on the personal data like the PI and PCI. One of the common sentiments, or there's two common sentiments we hear. Number one is like, hey, like it's in my systems, and I have permissions to use their data, so I'm fine. Like whether it's like generative AI or something like that. Do you think that that's true, or is that just like a false assumption?
Sorry, if a system owner's been given permission to use PII data, it's fine to train a model. Is that kind of what you're getting at?
Yeah, it's like leading the witness, we think that it is not correct because it doesn't abide with a bunch of regulatory principles. But do you think that that is a reasonable expectation that going back to your data scientist comment, like it's kind of new game for
Yeah,
people? Yeah.
I think that, we can let the lawyers fight out exactly what people think is legal and not legal in like different locations with different uses. It might be different in Nigeria, yada, yada, yada. Uh, it probably in most cases you'll lose that argument in the end, and you'll definitely lose in the court of public opinion anyway,
Mhm.
right? So it's almost like if you're trying to build a brand on this kind of technology that is that's going to last and that people are going to trust and that people are going to want to use, the handwriting's on the wall about the the way you handle personal data. You can try and convince yourself that it sort of doesn't matter for you and you've got this terms of service and whatever, but sooner or later, if you're big enough, that newspaper article is going to come out. Somebody's the model's going to release some data that you don't want, and you're going to have a headache. And it's not that hard to fix the problem
Mhm.
that you shouldn't. You just like should bake it in. It's to me, it's like you know, it's just do the obvious. It's like, should I not have data replication because it's not in my terms of service? Well, no, you should still have data replication because it's just a good idea.
Yeah. Yeah, it's like table stakes basically.
Yeah,
Um,
I think that's what it is. And I think it's cool in some ways. You see these, like the World Economic Forum, like the EU, like the Australia, Australia has a document on this stuff as well. You see these governmental and other bodies adapting to this technology and looming to regulate it much more quickly than they have in the past. And I think that's great. But I think that tells you everything you need to know about the spirit of the times on this subject.
second question to that is the one of the also common we think misconceptions, but if the statement that if I pseudonymize or if I redact or if I remove the data from my models, or from my training data set, I will get a worse model out of it.
Oh
True or
yeah,
false?
totally don't agree. It's use case by use case dependent. Like you said, there are
Hmm.
cases um, in IR and RAG type cases with LLMs where you might improve things by masking a little bit because you might take away these spurious hallucinatable facts.
Hmm.
Um, we found, so there's definitely like interesting nuances in different cases. By and large, we've never been unable to build a model of equal quality using one or another of these techniques. Pseudonymization, if you think about it, is very true to life as far as like the data goes, and it's very possible conceptually to imagine that you could train just fine in that kind of paradigm, and we've seen practically it's very possible for us to do it, and we've proven it out ourselves.
Yeah, that's good. Yeah, we've been doing a bit of testing on embeddings as well
Uh-huh.
too. And the initial thought is, oh, but if you redact the data, the embeddings will be different. And what we found is it's largely not the case, which is great. Other than when you get into issues where it's like d density of PI and like if you mask versus redact, you have like slight variations, but it's like second and third decimal point on a cosine similarity. So arguably, for most purposes, that's totally fine, right? Which is kind of interesting.
Yeah, I think, look, I mean, at the upshot, like, obviously we built all this stuff and we've been testing it to make sure that we like the performance of our models in both cases. So I kind of have the benefit of that. But now that I've done enough of that work, like I don't, if I was going to go build a new platform today, I don't think I would really bother doing many of those tests again. The way I would approach the problem is I would, either redact or pseudonymize, build the models, and if I found a performance problem, then I might start thinking about that. But it wouldn't be very high on my list. It would be like one of those like, well, maybe this is a crazy situation in which something like this matters, but like so like I'm at the point now where I wouldn't even like test for it, which coming from
Yeah.
a recovering physicist is a pretty strong statement.
Yeah, that's also a recovering physicist as well, so I
Oh, all
fully
right.
get it there. What other advice would you give to people? Just closing.
Good question. Let me think. I wrote down a couple of thoughts here when I was thinking about this conversation. Um, I mean, I think we hit a lot of the points that I think are most important. It's just but probably maybe to just like sum it up. I if you're not coping with this problem, this is not like a top level kind of first party problem for you. I shouldn't say first party. Let me put that more clearly. If this isn't on your list of like top three, four, five things that you've got to sort out for either, model service where you're using third party models or model training where you're building your own, you're probably behind the times now. You've got to make sure you have a strategy, just like you got to make sure you have a strategy for data recovery in on cloud. Just like you got to make sure you have a strategy for high availability of your databases in your structured databases that you have. You've got to make sure you have a strategy that's credible and will work for managing personal data with AI applications now. The stakes are higher, the models are less reliable, or just fundamentally like more ready to misuse this information just by their nature as LLMs. Not that anybody's done anything wrong. So, ignore it at your own risk. Like, wouldn't do it.
Great. We have one question from the audience, and then we'll do one question since it came in right now, and then would love your response, Joe. Then we'll hand over for Dan, and then for everybody else, we have a Q&A session afterwards as well too. So the question is PII PCI redaction also a good idea for data coming from public sources? Would love your thoughts on that, Joe.
Yeah, this
Like,
is one of those like, why not? Like why not? If you've already built, hopefully you've already built the architecture that allows you to make all this into like, just a switch you flip on service calls and a feature flag that you control. And if you've done that, then why not run this process on it? First of all, see what you find as far as like, is there PII, PCI data coming through this channel that I wasn't expecting? And, second of all, like just have that layer of protection. So if anybody ever comes knocking and says, you're infected with a problem that came from your data source, you can just show them the evidence that you're not.
yeah, I would double down on that and say like because we think about this problem all the time. Like the nature of our models are they detect PI. So when we create data for training it, we're hyper vigilant to make sure that there's not real data in there because yeah, like you don't want to be in a situation where like just use Reddit as an example of Reddit starting to sell some of their data and someone has a Reddit thread of credit card numbers, you don't want that in your model because then you're taking liability in a potential class action lawsuit for that data because you didn't do this annotation. So I very much agree. If it's coming from public source, why not? It's a safeguard protection
Yeah.
for
Yeah. And
sure.
like one quick point I'll make around this too is like sometimes you get the objection of like, well, machine learned models aren't perfect, therefore I'm not masking everything. Therefore, there's sort of like a funny logic there of like, therefore, it doesn't matter. right? And that's like really the wrong way to think about it for a couple of reasons. One, it does matter if you mask 98% of the data versus not. And then secondly, it really matters if you ever find yourself in a courtroom and you can't show that you took sufficient precautions. Like that's what the legal standards generally really are about. They're not actually about perfection. They're about, doing what is best and what is best in class in this case. That's where your protection comes from.
Yeah, great. Thank you, Joe. Really, really enjoyed the chat. We'll hang around for some Q&A, but I'll hand over to Brian, who will take us through like a little mini demo of how this would look like in practice. Well, so I will. Brian, I think if you can, should double check if you can share.
Let me just try right now.
Oh, good to go.
Good to see. And you're all seeing the private GPT. So I'll start off by apologizing for getting up during that. The wind shifted and started blowing papers around in the office. So I figured I should go deal with that before the demo. So this is a bit of a art of the possible. This is a chat interface that Private AI has developed. This is just an example of how you might want to go about redacting chat prompts before sending to an LLM. So I'm just going to start typing here. You can, by the way, you can go sign up for free at chat.privateai.com as well. So I'm just going to say, hello, my name is Brian. Tell me about yourself. And so you can see here, the first thing to note is we have redacted the first name. Hello, my name is Brian. So what's happening behind the scenes here is we're collecting that chat prompt and sending it to the Private AI de-identification service. We're detecting any privacy data that's found in the prompt and then back to the browser. So the data itself will never actually leave my browser or the de-identification service, which is running in your customer environment. We then send it outbound to the LLM. The LLM responds back, and then we do a follow-up call with the response, which will have a label embedded, and it will then replace it with the original data, all again inside my browser. So this is just a toy example. Let me do something a little more complicated. Mike and Joe are working on an acquisition deal worth about $5 million. They're meeting for lunch. So just minimize this to go over the plan. Just a few appropriate places to meet. And I'm in Toronto right now, so let's do Toronto. Now, if we send this out, there's going to be a couple of things that get redacted. So I'm just going to disable the location and the city. So now when we send this, you can see the names, the personal information are being redacted. There's an acquisition deal, the money is redacted. And then we're going to allow through Toronto. So in a customer deployment, an enterprise setting, you could tune this for whichever things that you feel are likely to be in the data that you actually want to redact for whatever regulatory use case you have. And so you can see here, even though we had redacted names and money amounts, you are still getting relevant and useful information. I've been to a couple of these. I would probably pick Allo as my favorite. So now let's take a look behind the scenes at what's happening. So this is a Jupyter notebook, a Google Cloud notebook. So if you take a look, this is the actual flow. So in this case, our application making the call to our private AI container, redacting the prompt text, and you get back two items. You get the redacted prompt plus an entity map listing all of the entities and the location in the original prompt. We then send the redacted prompt to any LLM, so ChatGPT, for example, and you get back a completion which has been redacted of personal information. And then we send that once again with the existing entity map plus the completion to our identification service, and it re-identifies that text and rehydrates it. So now I'm going to, oh, I've lost my connection to Google, so this may take a little bit of time. So we're going to install a couple of tools here. this will just set up a little bit of information about the OpenAI credentials. OpenAI, we have a prompt here for a key. So I'm going to paste in my private AI demo key, which you can go and sign up for as well. And then, yeah, the URL is loading properly. And so we'll start with this SEC filing. So we've pulled out some information about an SEC filing, and we've got this raw text. We'll set up a little bit of information about sending completion. So this is just taking the text that we'd like and sending the completion to private AI, or sorry, ChatGPT. And then this is the flow for a secure completion. So we will take the original prompt and then send it to private AI for de-identification. We'll then get the response and pull out the text with the redaction labels and do a completion, a ChatGPT completion. And then we'll get that response and we'll re-identify. Okay, we have a second example here as well, which is a marketing email. I believe this is a Salesforce email. And so you can see there's an awful lot of information in here. Okay, so de-identifying the SEC filing. So this will call with the SEC raw data. And we're going to ask the question of the LLM, summarize the following text as seriously as you can. So you can see this was what the redacted input was that we sent to ChatGPT. This is the completion that came from OpenAI. And then we re-identified. So you can see Sam Antar was charged with defrauding investors in the Syrian Jewish community. So this is the summarization of that SEC filing. Second, we'll do the same thing with our marketing email, only this time we're asking a bit more detailed of a question for the LLM, which products are mentioned in this email and who is interested in them. And again, we'll go through that same process. And now you can see the re-identification will say products mentioned in the email, decision split, journey data, contract data synchronized, etc. And then the interested parties. And all of this was redacted prior to sending to the LLM. And I think that's it for the demo, and I will pass it back to Mike.
Thank you, Brian. The thing that I love about those demos is you can clearly see the redactions and how they have little to no impact on a fairly complex text like document summarization or information extraction, which it's like I know slightly different than the conversational one, but I like them as kind of a proof point to say like all the LLM really needs to know is like there's an entity that is linked to another specific entity. It doesn't matter if it's redacted or not. You still get some really good performance from it. So it's again for us one of those why not? Like if you get a good performance from it, why not redact it to minimize exposure? So with that, would love to open it up to questions, any Q&A. This QR code on the right-hand side here is a GitHub repo that we have that's public that has a bunch of different examples of how we think is a good sort of privacy preserving flow of a lot of different things as well. But yeah, again, thank you, Brian. So question number one, Joe, what was the biggest surprise you encountered during your privacy journey? Like you was like just, gee, I didn't know this. But
I mean, I mentioned this a little bit before. I don't think I had a great understanding for how, sort of nuanced and fiddly it was going to be to look for things like names and addresses in across the globe, right? Like I just kind of like continually surprised with regionalization problems for language models. That's just like an annoying and like very expensive problem to manage. So I wish I had, and maybe I was just being kind of thick, but I wish I had appreciated that problem in its fullest form, on day one.
yeah, it's a good explanation of our value prop, which is great. So thanks.
Yeah, well, I mean, it's like we use you guys for a reason. That definitely saves us stuff that we just don't want to be good at. Like, or it's not that we
Yeah.
don't want to be good at it, but it's like there's no strategic value for us in being good at that.
Yeah, exactly, which is great. Second question, So it says, so essentially here you are protecting your data by not sending it to OpenAI. That is true. That's yes. Follow up to that is it a good idea to use it if we have our own version of an open source LLM? I'll let you answer that one first, Joe, to get, I'd love your sort of your response to that without me biasing the response.
Yeah, I think if you're training, it's a no-brainer. You should redact because you just don't want the model weights to pick up any of that stuff. At inference time, I think, it's I guess and Mike, feel free to add on to this, but I guess like the utility I would see with putting the masking in is just, am I limiting the surface area of where this data goes within my own systems as effectively as possible? And that's kind of one of these like always a good idea as well. And why not if I can get away with it without like impacting performance in any meaningful way. Basically, that simplifies and compartmentalizes your own architecture, and then it allows you to move faster on the LLM side in case you're worried about, like anything that's outside of the PII zone is going to be just a more agile development environment, kind of by nature, if you're managing this stuff carefully.
Yeah, I would agree with that. There's a lot of different answers I see. The interesting one that comes up. If you make the assumption that somebody has an isolated Falcon or Mistral deployment in a VPC in AWS, right? The training data is kind of self-explanatory. You don't want to put in stuff that you don't want memorized on top of that. I've heard a lot of different use cases on inference time where it matters too. So hypothetical example, if a company goal is to have one LLM for the entire company, all the corpus of the data that the HR team can use and the sales team can use to ask questions about company documents and different data points. Redaction on input actually helps potentially with roles-based access restriction. So if it's a salesperson saying like, what is the salary of Jane? You shouldn't be able to answer that question or ask that question to the salesperson because you don't have the HR credentials to do that. So a lot of ways I've seen people trying to do that is then to have like one LLM per department, per region, per something like that, which then gets you into a fairly complicated model stack, I suppose. So it's like an early area of investigation, but a lot of the interesting use cases we've seen is by minimizing what you put into the inference time can actually help with some of the data privacy, even on first-party internal data as well too. So
Yeah,
it's interesting.
I think that's an important point, and I guess there's a larger point under here too, which I'm just starting to appreciate. Which I guess I would put this way: like, if your strategy with an in-house LLM to get it to give you like factual and trustworthy answers is to train the model weights on data and leave it at that, I think you have a problem right there.
Yeah.
I think your strategy should include retrieval augmented generation for prompting. It should include direct interface with other systems that provide deterministic and factual data that it can access and purvey directly to users. That's how you get these things to be usable and somewhat bulletproof. Otherwise, you're chasing that training dragon forever. And then the other problem you have, if that's your strategy, is you don't have a good way, like you don't have great mechanisms to control it. It's just like train more and hope it works better next time, or train a little different and hope it works better. And you just end up in like this kind of nasty whack-a-mole game when it comes to accuracy, which is really what you don't want.
Yeah. Yeah. It'll be never ending.
Yeah.
Case.
Yeah.
Yeah.
I mean, maybe someday we'll have a new architecture that obviates all of this, and then we can all go home and probably no one will need to work anymore, but we'll see.
We will see. There's another question. What do you see as a workflow with emergent agent frameworks for RAG type applications?
Yeah, I would say some thoughts here. I'm not exactly sure what Andrew means by workflow specifically here, but I'll try and address it. And Andrew, if you want to say more in the chat, I'll try and keep an eye on it too. So I think the agent frameworks are really interesting in that they're very flexible. They're not always the most controllable of the, sort of LLM inference or prompt chaining techniques, let's say. We've developed a bunch of internal building blocks that look a little bit different than sort of like your standard React agent or things like that that just are a little bit tighter, where you can put a little bit more tight controls around which path your model execution engine kind of goes down to construct its prompt. And we think those are good. So I would recommend experimenting directly and not just taking stock from LangChain or whatever environment you're in. Don't just take those stock ways of constructing and managing prompt chaining. Like, work on this problem directly on your own if you really want high performance, high accuracy, and high quality applications.
I would very much agree with that as well too.
Yes. So don't be afraid to extend. Don't be afraid to build builder tools around it. Don't be afraid to try something a little different. I don't think this ecosystem is totally settled down yet. I think we'll see new tools for this stuff in the next couple of years, and there may be some migrations that people have to have. So also don't put all your eggs in one basket.
Yeah. Is it best to use fake data to train your model? If yes, how would that change how accurate your model is? I'll go
Depends
to
on what
you
you mean by
first, Joe.
fake. I hate to give a Clintonian answer there, but yeah, it really depends on what you mean by fake. If you mean like pseudonymized data, then go for it. I think we've seen really good performance there. If you mean, you know, like, just be careful with, make sure you understand how that generation function that's creating your quote unquote fake data works. Make sure you test it in real contexts, and you can see the limitations. Like, the devil is really in the details on that one.
Yeah, I'll agree and add to that as well too. There's in structured data, it's actually a little bit conceptually easier to think about. Like, so I'll say, Joe, you and I both as ex-physicists, I could concoct whatever data that I wanted with a single Python script to match the model that I was trying to do.
Right.
But should I do that or not? Probably not. You don't want to make data just for the sake of making a model. I've seen a bunch of synthetic data mechanisms and different products recently that are just random synthetic data, which is okay, but you have to realize that synthetic data isn't the context of the business data that you have. We ran into this when I worked at Salesforce, where we actually found out that heuristics in opportunity prediction sometimes worked a little bit better because it was hard to codify based on some synthetic data that we have. So it very, very, very aggressively depends on what your problem type is.
Yeah, and just to add, I know we're at time, but just add one quick point on that. Like, for the mathematically inclined in the audience, you can go create a distribution on structured data and say, here's what that looks like distributionally. Now I can go create fake data that's faithful to that distribution. The distribution of, if you're talking about unstructured data or language data in particular, that sucker's an infinite dimensional vector space. You're not going to find distribution that like is the conversational distribution. If we could find that, we'd actually be done with conversational AI, really. Like, that would be that kind of is the problem of like teaching models to use language.
As a very infinite dimensional vector space is a good way to end it, I think. That's
And
that's
maybe it's the
good.
worst way to end it.
Well, I like vector spaces. Like, the most nerdiest way to end it is there now said. But, all right. Thank you, Joe. Really appreciated the time. Thank you, Brian. And thank you for everybody for attending. This was great.